Hey everybody, this is Mr. Ainsworth, and we're going to get into part three and finish this second semester geometry final review. So here we go. Have your resources next to you. I suggest probably have your calculator next to you because we will be using it. Um, because these formulas contain pi and pretty detailed arithmetic computation. So have your calculator, have your formula sheet nearby with your surface area formulas and your volume formulas nearby. Here we go. All right. We have a right cylinder cone. That means the vertex is directly above the center of the base. It's at the height is at a right angle to the base, or right angle to the diameter here. So this right cylinder cone has a diameter of 12 centimeters. You can tell right here. That's the diameter. All right, that means that the radius right here is 6 centimeters. That's 6, and that's 6. 6 and 6 is 12. You just have to take the diameter divided by 2 to get the radius. I'll label that radius right here. All right. And our goal is to find the volume of it with a slant height of 10 centimeters. So this is slant height. All right. And this is the height. Now, as you can tell down here, the volume of the cone, as we put in class, is 1/3 the base area times the height. But the base is a circle, right? And everybody knows that since the base is a circle, it's pi times radius squared. That's why you see this formula down here, 1/3 times pi times radius squared times the height, okay? If you were with me, we stepped it out. We did base area, then volume. Or you can write it as one single formula. It doesn't really matter. Okay, it all depends on your preference. So if we're going to find the volume, we got to take 1/3 of pi times radius, 6, 6 centimeters squared times the height. Now we don't know the height, so you got to find the height first, right, before you do anything, because as you can tell, I don't have enough information, right? So what we do is we look at this right triangle. Every cone has a right triangle on the inside of it. All right, we kick in your Pythagorean theorem, which works for all right triangles. All right, 6 squared plus h squared is equal to 10 squared. That's 36 plus h squared equals to 100. Subtract 36, and you get h squared is equal to 64, which means h is 8. All right, so this is 8 centimeters tall. That's the height. So let's bring it in over here. So we have 36 times 8 times pi. Now, 36 is divisible by 3, so 1/3 times pi times 36 times 8. See, I mean, a third of 36. Do a little mental math here. That is 12. 12 times 8, that's 80 and 16. That's 96. So volume equals 96 times pi, all right, cubic centimeters. All right, because volume. This area right here, pi r squared is area times height, and that gives you cubic centimeters. All right, remember these little cubic centimeters back in your parents', kitchen. You have little cubic centimeters. All right, and there you go. You got the volume there. So the exact answer is 96 pi cubic centimeters as a decimal. Well, then figure it out, right? Go 96 times pi. All right, hit the enter button, and you get about 301.6. So 301.6 cubic centimeters. And that's the volume, or the number of cubic centimeters inside of a right cylinder cone with slant height 10 centimeters and diameter 12 centimeters. Okay, on this one here, what do we have? We have a diagonal. Okay, it's 10 centimeters. In a rectangle, what is the perimeter of the rectangle to the nearest tenth? All right, the perimeter. Now, the perimeter is the distance around, so keep that in mind. Perimeter equals distance around the rectangle, right? Around rectangle. Well, that means we got to find all the four sides. So what we're going to do is we're going to focus in on the 30, 60, 90. Okay. Now, I know there's a right angle here because we have a rectangle. So that means that's a right angle, and so is that, right? So if that's 60 degrees, all right, that's 30 degrees, 30, 60, 90. This is something you're familiar with. Now, to get from hypotenuse, all right, hypotenuse to the short side, opposite of the 30, you got to take half of it. So you got to divide that by 2, right? And so you get a 5 centimeter width here, and that means that this is 5 centimeters here. Now to go from here to the medium side, you got to multiply by rad 3. as you guys know. So this is 5 rad 3, and so is this. This is 5 rad 3. So the perimeter, if you want to step this out, is 5 rad 3 plus 5 rad 3 plus 5 plus 5, right? Let me write a little bit better. There we go. Well, I get 10 rad 3 here plus 10. That's the perimeter. There's your exact answer in terms of centimeters. Now it says rounded to the nearest tenth, right? If you read the directions. Okay, there you go. So all you do is type it in. So 10 times radical 3 or root 3. All right, and on this calculator, you have to get outside the radical symbol and then add 10. All right, so it's about 27.3. So the perimeter is approximately equal to 27.3 centimeters all the way around. That's all there is to it. Piece of cake. All right, now next one, 45. You guys, Rob's looking up at the flagpole at 57-degree angle. The flagpole is 20 feet tall. About how far is Rob standing from the base of the flagpole? This doesn't give his height. So this is not a very good problem the way it's written here, because he's obviously above the ground, which where the height isn't has to be taken in consideration. So, but if he's on the ground, he's looking at the flagpole. Here's a flagpole. Oop, there we go. So there's a flagpole right there, and he's looking up at a 57-degree angle here, and the flagpole is 20 feet high. How far is he from the base of the flagpole? So you got to find x right there. Well, I know that this is the opposite side, okay? And this is the adjacent side. And if you guys have learned any trig, and you learn SOHCAHTOA, then you know that this is a tangent function problem, because opposite and adjacent is a tangent ratio. So if I was going to solve this, I'd take tangent of 57 degrees is equal to opposite 20 divided by x. All right, here, I would multiply both sides by x to clear the fractions. Boom, right there. And so you get x times the tangent of 57 degrees is equal to 20 divided by the tangent of 57 degrees on both sides. And then you get x is equal to 20 divided by the tangent of 57 degrees, which is your exact answer. But as a decimal, you got to figure this out, right? Now in this calculator here, make sure that you're in degree mode. If the calculator had radians highlighted, you'd have to go over to degrees, hit the enter button, and change it. So go second mode, which is quitting out, and start your calculation. 20 divided by the tangent of 57 degrees. God, this is slow. So you get about 12.99. Okay, 12.99. There you go. So 12.99, we want to round it to, does it say? It doesn't say. So 12.99 or almost 13. So the distance, x here, is equal to 12.99. We're in feet here, or roughly say x is approximately equal to 13 feet, if you want to round it to the nearest whole number. All right. Number 46, square is a perimeter of 44 inches. What is the length of the diagonal? Well, you need to know its size, right? So if you have a square here and the perimeter is 44, 44 divided by 4 is 11, as you guys know. So the sides of the square are 11. But what's the diagonal? Well, we know it's a 45, 45, 90. So all you do is multiply 11 by root 2 right here, times by rad 2, and you get 11 rad 2 and you're done. Or you can use your Pythagorean theorem. Either one, but that's it. Okay, next one. What is the length of the altitude of the equilateral triangle? Well, we have a 30, 60, 90 involved. So what you want to do is start going for it here. So if that's 8, that's 4, that's 4. The hypotenuse to short side is half, and then from short side to this side is, you have to multiply by rad 3, so this is 4 root 3 here, and that's the altitude or the height. Okay, the altitude or the height in this case is 4 rad 3. And that's all there is to that one. Okay, number 48. What's the height of a cylinder if the volume is given? So you have a cylinder here, All right, the volume is equal to base area times height. The volume is given, so and the radius is 5. So here the radius is 5. Okay. The base is a circle, right, for a cylinder. So it's pi times radius squared times height. There's your volume strategy. The radius is given, the volume is given, so substitute it in. So 335.2 is equal to pi times radius of 5 squared times height. And you got to solve for the height here. So 5 squared is 25, so you have 335.2 is equal to 25 times pi times the height. All you have to do is divide both sides by 25 pi on both sides, right? So divide by 25 pi here, and then kick in your calculator and make sure you use parentheses around the 25 pi. So here we go. We're going to take 335.2, we're going to divide it by the quantity of 25 pi. You can see there, you see the use of parentheses right there, and hit the enter button and get about 4.27 there. Okay, and that's looks good to me. I think that's it. Okay, so let's write that down. 4.27. 4.27. In this case, inches. Okay. All right, next one here. What do we have? We have asked us, what is the value to the nearest tenth of this? Okay. So what we'll do is we're going to get creative. We're going to form a triangle, right? We're going to swing the radius around. This is the radius. I'm going to draw the radius here. Right here, and that's 12 as well. There's a right triangle here, and I'm going to focus in on the right triangle, and I'm going to find what y is. Okay, x is 2 times y. X equals 2 times whatever the y value is. So I got to find y first, and then I can find x using your Pythagorean theorem, of course. So y squared plus 9 squared is equal to 12 squared. What does that give us? So y squared plus 81 is equal to 144. Subtract 81, and you get y squared is equal to 144 minus 81. 144 minus 81, what do you get, right? You get about 63. So, and then you square root. So the square root of 63, I don't know, what is that? Let's see, let's square root it. So let's go second x squared, which is the square root. Enter in 63, hit enter, and then you got to double that to get x, so times 2. There we go. So 7.94 is y, 7.94, but x is equal to 2 times that, 7.94. Let's look at the calculator again, 15.87. So 15.87 would be the value of x. Okay, meters. Although that's all there is to that one. Let's keep it going. Let's rock and roll. Here we go. So, sketch the cross-section of the plane that is perpendicular to the base. Okay, perpendicular. So if you chop this right down the middle, but on an angle, like right here and right here, if you slice it right there, straight down, you get a rectangle. So it's a rectangular cross-section. So rectangular cross-section. Okay, it can't be any more difficult than that. Okay? All right, so number 51, what is this? This is another chapter 12 circle problem. So let's see here. You got to find the arc here, A. You got to find the inscribed angle, B. And you got to find another arc, C. Okay, so let's get creative. So I'm going to use color now. So this inscribed angle here is 68 degrees. So this arc right here that I'm highlighting from here all the way to here, where start to finish, right? It's got to be 2 times that, so I got to double. So 2 times 68, 68, oops. So 2 times 68, that's 120 plus 16, 136, so 136. This is 136 degrees here. All right, that means that 100 plus A gives you 136, so A must be 36 degrees. Let me write this a little bit better here. 136 degrees. Okay, so 100 plus something equals 136, so A is 36 degrees. Arc. What's B? B is the inscribed angle. Well, I need to know these other arcs. So let's see here. Let's work on this. I know that all these arcs add up to 360. So now I want to take 114. I want to take 36. Actually, no, 136. I want to add it together. So I get 250. All right, now 250. So 360 minus 250. All right, 110. So this must be 110 degrees. So what in the world is angle B? So let's highlight that. Now angle B is also inscribed, but it intercepts a different arc. So from here all the way to there, right? And that arc in blue is 100 plus 110, which is 210. So half of that, right here, divided by 2, all right, is 105. So 210 divided by 2 is 105, and that's one way you can do it. Not the only way, of course, but that's one way. All right, you go ahead and be creative. You can go do it another way. All right, on the volume, okay, find the exact volume of a sphere. Now you need to know the crazy formula, 4/3 times pi times radius cubed. So you're going to take 4/3 times pi times 4 cubed. Now what is 4 cubed? 4 times 4 times 4, that's 16 times 4, that's 64. So this is 4/3 times pi times 64. I got to multiply, obviously. Now 4 times 64, that's 240, plus 15, that's 256. So it's 256 pi divided by 3. So 256 pi thirds cubic millimeters. All right, that's the volume. All right, number 53, getting there. Okay, sketch the cross section again. Okay, that is parallel to the base. Well, any cross section parallel to the base has the same cross section as the base. So parallel here to here. Look at this. Parallel, parallel, and then the reds are parallel, and then parallel, parallel, right? So the cross section is congruent to the top base or congruent to the bottom base. Okay? So the cross section in this case is a triangle. So it's a triangular cross section. And the only reason why I know it's a triangle is because when it's parallel to the base, it's congruent to the base. All right, congruent to the either top or bottom base. I say top base just because you can see it. The bottom base is down here at the bottom. Okay? All right, that's it. Number 54. What do we have? So Ryan has to choose 3 essays to write his history exam. All right, there are 5 prompts given, and how many ways can you make a choice? Okay. So what do we do? Well, let's do it this way. Let's use counting principle. So he has 3 essays to write for his history exam. There are 5 prompts given. Let me think here. Okay, so there are 5 prompts given, and he's got to choose 3 to write out of the 5. So it kind of sounds like a combination. So how many ways can we choose 3 out of 5? So it's actually 5 choose 3. Okay, or n choose r. So n choose r. That's n factorial divided by n minus r factorial times r factorial. So in this case, we want 5 choose 3. We have 5 given, but we have to choose 3 out of the 5. So we say 5 choose 3. and that's equal to 5 factorial divided by 5 minus 3 factorial times 3 factorial. What is that? Well, it's 5 times 4 times 3 times 2 times 1 divided by 2 factorial, so 2 times 1, times 3 factorial, 3 times 2 times 1. Well, all of these cancel out with all of these. 2 into 4 is 2, and 2 times 5, well, that's 10. So there's 10 ways, okay? There's 10 ways to make your choice, okay? That's all there is to it, okay? It's a combination. Numbers are pretty small here, so you don't need a calculator. Okay, next one. We got to find the volume of a triangular prism. All right, well, guess what? It's a triangular prism, so the base is a triangle. So you got to find the area of the base first, because the volume, as a strategy, is the area of the base times the height for all prisms. You should know that. So we got to find the area of the base. All right, the distance between the bases is called the height. This is the height right here. Distance between front and back. Here's the back in blue. There we go. It's called the height. So that's the height of it, but what's the area of the base? I don't know. I got to figure it out. So it's a triangle. So what I'm going to do is going to take a look at it. I'm going to call this. I'm going to call the height x here because it's different than h here. It's going to be. Obviously it's different. So I got to find x first, which is the height of the triangle, because I need to go height of the triangle times the base 10 divided by 2. All right. We'll do that over here. So height, or base times height, excuse me, base times height divided by 2 for any triangle. The base is 10, so it's going to be 10, all right, times something divided by 2. I got to find x though, so let's find x. Using the Pythagorean theorem, so x squared plus 5 squared is equal to 7 squared. So I have x plus 25 equals 49. That means x squared is equal to 24. That means x is equal to the square root of 24, which is a little under 5. It's going to be 4.9 something. So the square root of 24, all right, it's 4.9. Okay, 4.89. So 4.89. That's the height of it. So I have to take my answer there, 4.89. Let me write it better here. There we go. So base times height. So base is 10 times the height, 4.89, all divided by 2. So on the calculator, I already have the number in here, so I just go times 10 divided by 2 and hit the enter button. 24.49. So we've got my base area of 24.49. So the base is 24.49. I'm going to take this answer here. I'm going to bring it up here. So the volume is base area 24.49 times the height of it, which is 11. So the answer is already in my calculator. So I just go times 11 and hit enter, 269.44. So 269.44, in this case, cubic centimeters. Okay? Okay. Next one, 56. An ice cream shop offers 10 different flavors of sugar-free ice cream. How many different ways can 3 flavor bowls be created? Kind of sounds like an ice cream problem. Let's see. Now in this one, let's see. 10 flavors, choosing three flavor bowls. So once again, you have 10 flavors and you're choosing 3. So this sounds like 10, choose 3. So as a formula here, it's going to be 10 factorial divided by 10 minus 3 factorial times 3 factorial. Remember, it's n factorial divided by n minus r factorial times r factorial for any combination. So here we go. So 10 factorial, 10 times 9 times 8 times 7 factorial. I'm going to stop there because I see a 7 factorial here, times 3 factorial, which is 3 times 2 times 1. Well, the 7 factorial is going to cancel out with this. Let me see, 3 into 9 is 3, 2 into 8 is 4, so it kind of looks like 30 times 4, 120. So 120 ways, all right, to pick a 3-flavor bowl out of 10 different flavors. You got a lot of choices. Lots of choices. All right, and that'll make anybody feel good. All right, number 56. Oh, that was number 56. Okay, next one in a minute. So what's going on here? So, okay, come on, computer. Here we go. So what we want to do is take this rectangle here, and we want to revolve it around the y-axis. Now here's the y-axis, and this is the x-axis. So what we want to do is revolve it this way. Okay? And we want to sketch and identify the solid revolution after a 3-dimensional rotation about the y-axis. That's important. Find the volume of the solid formed. Okay, no problem. So we're going to swing it around this way here. And so what's going to happen, if I reflect this across the y-axis, you're going to get an identical rectangle over here. All right, this distance here is 6. All right, and if you swing it around, it's going to look like this. Oh my goodness, oh my goodness, it's going to look like a cylinder here, guys. Okay, it's a cylinder. It's a cylinder with radius is equal to 6. And the height right here, if it's 6 comma 4, this is the height. Well, that's obviously 4 because it goes, to get to 6 comma 4, you got to go right 6 up 4. All right, so what's going on? Well, we got to get the volume, right? It's base area times height for any prism or any cylinder. Now the base is a circle, so it's pi times radius squared times the height. That is equal to pi times 6 squared times the height of 4. That's pi times 36 times 4. That's 120 and 24, 144. So this is 144 pi cubic units for the volume. Now that's an exact number, so let's get an approximate number, okay, as a decimal. So 144 times pi, and you get a 452.3 0.39. So 452.39 cubic units. So you got exact and approximate. All right. So number 58, find the volume of a rectangular or right triangular prism. Okay, now it's a triangular prism, right? So the base is a triangle. That's where the name comes from. All right? And there's a right angle there. That's where the word right comes from. Okay, so we need to figure out the area of it. So the base, this one here, the base, capital B, is a triangle. Space times height divided by 2. So 3 times 4. Divide that by 2. So the base area in this case is 12 divided by our 2, or 6 square meters. The height is the distance between bases. So right here, this is the back. All right. What you see in blue is in the back. What you see in red is obviously the front. And the difference or the distance between the two is called the height right here. So the volume is base area times height. So the base area, we already know, is 6 times the height of 6. Now these are square meters, and these are in meters, and that's how you get 36 cubic meters for the total volume. Okay, moving on. Okay, so number 59. So how many different outcomes are possible if a person rolls one die, flips one coin, and spins the spinner with numbers 1 through 4? This is a counting principle. Okay, so let me see. We have one die. Okay. We're going to assume it has 6 sides, although that's not always the case. You have one coin, all right, 2 sides, and you have a spinner. It has numbers 1 through 4 in it, so it's got 4 possible outcomes. The counting principle says you got to multiply the possible outcomes. So the number of possible outcomes total would be 6 times 2 times 4, or 6 times 8, or 48 possible outcomes. Different outcomes, possible outcomes, PO. Now this one here, you got a 18. You got 18 soccer teams enter a tournament. How many different ways can the champion and runner-up be selected? Well, let's use the counting principle again because it's easier than using a permutation. The champion here, champ. All right, there's 18 ways or 18 different teams, so 18 different people can be champ. Runner-up. Well, let's think about it here. Now, if only one person can be the champ, and the rest could be the runner-up. So there's got to be 17 possibilities here. Counting principle says multiply them together, so 18 times 17. Well, what is that? 18 times 17, you get 306. So there's 306 different outcomes, or different possible outcomes. All right, PO is possible outcomes. All right, on this one here, bag contains 10 red marbles, 6 blue, 4 green. Okay, so I can already count the total already. So total marbles, let me see, 10, 6, and 4. 4 and 6 is 10, plus another 10 is 20. So the total is 20. Drawing one marble from the bag, find the following probabilities. So let me see, there's 6 blue, and there's 4 green. 6 plus 4 is 10, so there's 10 out of 20, or 1/2, which is 0.5 or 50%. So there's a 50% chance to get a blue or a green marble out of 20 because there's 6 of the blue and and 4 of the green. All right, now we want to draw one marble, replace it, this key word here, replace it and then draw again. Okay, so replacing it versus non-replacing it is important. Replacing it means the total doesn't change. The total does not change. You have to understand that. Okay, so probability of blue and then green. Well, what we want to do is we want to take the probability, again, the blue one, multiply it times, here, let me write this a little bit better, times the probability of getting a green. So what is that? Well, probability of blue, there's 6 blue out of 20, times probability of green, and there's 4 of them out of 20 again because we replaced the marble. We didn't keep it out. If we took it out and we didn't replace it, I would change it from 20 to 19. So what is that? This is 3/10 times 1, oops, 1/5, and so that's 3/50ths. So the probability is 3/50ths as a decimal. 3 divided by 50 is 0.06, so 0.06, and that's 6%, so it's low. All right, low. Even 50% above is low too. Anything above 80 is high. Anything below 70 or 80 is low. I wouldn't bet on it. Now this one here, drawing one marble and not replacing it changes things. If you don't replace it, hang on. If you don't replace it, that's going to change the total. So the probability of getting a red and you want to multiply it by the probability of getting red again. All right, but this time we're not going to replace it. Do not replace it. So this time it's going to be, let me see, red, 10 out of 20 times, you got to reduce the, well, you don't have one, you have one less red and you also have one less in the total. So it's going to be 9 out of 19. So let me see, what is that? So it's 1/2. So 1/2 times 9/19. Okay, that gives you 9/38. So 9/38, what's that? I don't know. 9 divided by 38 is about 24.24. Make sure. Oh, you know what? I read it. I didn't read it correctly. We don't want a red. Okay, so let me change this. So probability of getting red is 10 out of 20 because there's 10 red marbles out of 20, but not red. Well, that means you're either blue or green, right? So that's 10. So 10 out of 19. All right. So that's 1/2 times 10/19. What's that? That's 10/38. So 10/38. What is that? So 10 divided by 38 is 0.26. So 0.26 or 26%. All right, and I'll be back in just a minute. Okay, 2 6-sided dice are rolled. So one die number 1 here, and die number 2 right here. Each have 6 possibilities because it says 6-sided. Find the probability that sum is 8. Okay, now if you want sum equal to 8, there's only a few ways you can make that happen. You can make the obvious choice of 4 and 4, or 5 and 3, 3 and 5, 6 and 2, 2 and 6. And as you can see, there's 5 ways to do it. Okay, 1, 2, 3, 4, 5. So the total possibilities is 36 possible outcomes. So the probability that the sum is 8, so the probability that you get a sum equal to 8 is equal to 5 out of 36 ways. Always number favorable out of total. So you take 5 divided by 36, you get 0.14. So this is 0.14, and that's equal to 14%. So you have a 14% probability that you're going to get a sum of 8. Not very high at all. So I wouldn't bet on it, guys. Okay. Okay. Next one. Find the volume of another cylinder. Okay. Now the diameter is given. So if the diameter is 10, that means the radius here is obviously 5. So to find the base area, which is pi times radius squared, you're going to take pi times 5 squared. That's 25 pi. That's your base area. The volume is base area times height. So you're going to take your 25 pi times the height of 16. Now 25 times 16, that should be 400, but let's check. So 25 times 16 is 400, so you get 400 pi cubic centimeters here. What is that? It's over 1200, so you take that and you multiply it by pi, and you get 1256.6. So 1256.6 cubic centimeters. All right, and then number 64. Holy cow, there's more. Okay, 64. Find the volume of a sphere. Okay, now a sphere. That's 4/3 pi r cubed. Okay, if the circumference is given, so C is equal to 12 here. 12 pi centimeters. So I'm going to take this down here. We know that circumference is 2 pi r. I need to know the radius. So since 12 pi is the circumference and that's equal to 2 pi r, you guys got to be thinking 2 pi times what gives you 12 pi? And the answer's got to be 6 because 6 times 2 is 12. So this one's fairly simple. So the radius is 6. So you take 4/3 times pi times 6 cubed. Sounds like we did this already. So what is 6 cubed? 6 raised to the 3rd power should be 216. So 4/3 times pi times 216. 216 times 4. So times 4 divided by 3. All right, it's 288. So 288 pi is the volume. As a decimal, you got to multiply it by pi. All right, and you get about 904.78. So 904.78 cubic centimeters in this case. So what we had to do is you had to step this one out. We're going to first use the circumference to find the radius. Step 2, we find the volume. Okay, and that's all there is to it. All right, next one, we got a few more and then we're done, thank God. Okay, so find the exact perimeter. So let's label the sides. We got 15 here, we got 12 here, and we have a 6-inch radius, 6-foot radius here. That's the radius. So we need to figure out what in the world, half a circle is. So the circumference is 2 pi r. So 2 times pi times radius of 6. So the circumference is 12 pi. But we only got a half a circle, right? So half a circle is half of 12 pi, which is 6 pi. So the perimeter is 6 pi plus 15 plus 15 plus 12. So 6 pi plus 15 plus 15 plus 12. And that's going to be 30 and 12 is 42. So 6 pi plus 42. There's your exact. Does that make sense? Okay. So now, what else do we want to do? Well, what we want to do is find the area. It says exact, right? So we don't need a calculator here. The area of a semicircle, and then the area of the circle is pi times radius squared, or pi times 6 squared, or 36 pi. But we only have half of that. So half of that, you got to take half, okay? 36 pi. Divide that by 2, plus the area of the rectangle, which is 12 by 15. Now 12 by 15, so 12 times 15, it's 180. So inside here, there's 180 square feet. So you have to add 180 square feet. So that's 18 pi plus 180, and these are in square feet. The perimeter is just in feet. Okay, we're almost done. Number 66. Okay, building a gate for a fence. The diagram shows the gate shown. How long should the diagonal support the gate? Okay, square gate. Who makes square gates? Okay, so how long is this diagonal? Well, all you have to do, since it's a 45, 45, 90, is multiply by rad 2. So x is equal to 4 rad 2. And you're done. Okay, why? Because it's a 45, 45, 90. It's too simple. Okay, and I think we're done. Thank goodness. Okay, there you go. Now, remember, this is a video, right? So you can, all right, do what good students do and rewind it if you want. Listen to it again. Practice, print off another student copy. Make sure you can do it by yourself, because it's one thing listening to me and copying and taking notes, but it's another thing doing it on your own. So practice, and I'll see you in my next lesson. This is Ainsworth signing off. Bye-bye.